If I know the exact height of the Eiffel Tower, and I take an angle to the Eiffel Tower, I can then determine my exact distance from the Eiffel Tower based on the angle I take. If I don't know the actual height of the Eiffel Tower, but I know my exact distance from the Eiffel Tower, I can then, with my angle, determine the height of the Eiffel Tower because I have the distance. So you have to have the size to know the distance, or the distance to know the size.
That was Brian's logic, and he tries to convince people that the Earth is flat. This time he's trying to use trigonometry to prove his case. Trigonometry might sound scary, but it's all just about the relationships between the sides and angles of a right-angle triangle. So how do I know that the tangent of this angle equals this? Let's compare the opposite side with the adjacent to see why. Now these relationships hold true no matter the size of the triangle, and as Brian just said, if you have an angle and you have a distance, then the height of the triangle is known. And that's exactly what we have in this scenario with this right triangle. We all agree that Polaris is generally considered to be located at 90 degrees above the North Pole, and the angle we see it at will match our latitude. Also agreed is the distance between each degree of latitude, which is about 69 miles, 111 kilometers, or 60 nautical miles. This means we have a distance and we have an angle, so Brian should absolutely be able to determine the height of Polaris. But do you see the problem? As the observer moves, Polaris has to physically change in its height while the 60 nautical miles distance for every degree of latitude is maintained. And as I recall, the Eiffel Tower didn't have to change its height when measuring to that. Adding multiple observers to the situation just highlights the problem even more. So the idea that a right-angled triangle is formed between the observer, the ground position of the star, and the star itself has to be false because objects do not physically change in height when we walk toward or away from them.
Don't use that stuff, Pete. This is absolutely infuriating, you complete retard. Any evidence you can acquire an elevation angle measurement to Polaris? From a curved baseline? Like on a globe? I'm thinking no!
Nathan Oakley 1980 is yet another YouTuber that spreads misinformation regarding the shape of the Earth. And he will prove me right by instantly rejecting the basic geometry I'm about to show you. This is the observer, and here are their coordinates. This green vector points straight up from this location, while this white one points to a very distant Polaris. This yellow angle is the zenith distance, and if we multiply it by 60, it will give us the length of this arc. That's it. That's the geometry. I've just debunked Nathan Oakley.
Have you really, Petey? Really? Well, you just measured it with the flat earth angle on screen previously.
You see, both Brian and Nathan want you to believe it's impossible to measure this angle. But if you can point straight up with one arm, and then point to Polaris with the other, then you have all you need to prove them wrong.
No, Petey! Hello?